In order to graph linear inequalities, we can start off in a similar manner to what we did with linear equations. Notice that this is still something of the form mx plus b. So we can still look at that value for b, which in this case is 4, giving us the y-intercept of 0, 4. And we have a slope of negative 1/2, which means to get to that next point, we'll go down 1 and to the right 2. And we have 2 points which we could now connect as a straight line. But we get an extra step here with inequalities. We either have to graph this as a dashed line or as a solid line. In this case, we have a strict inequality. Anytime we have a strict inequality, we're going to use a dashed line to actually draw this line that we are plotting out. So we'll connect these points. With a dashed line. The reason that we do that is because the points along this line aren't actually solutions to the original inequality. For instance, our intercept is 0, 4. If we plug those values in, we would get 0 is less than negative 1/2 times 0. I'm sorry, that should be 4. 4 is less than negative 1/2 times 0 plus 4, which would give us 4 is less than 4. That's clearly not true. So this line that we've constructed is a boundary line for our solutions, but in this case, because of that strict inequality, the points on that line themselves are not solutions. But this inequality does have points that are solutions. And once we have this boundary line, those points are either all of the points above or all of the points below this line. To determine that, what we need to do is look at a test point. As long as our line doesn't pass through 0, 0, that's a really easy test point to choose just because it's easy to evaluate. So we're going to test that point 0, 0 by plugging it into our inequality statement. We'll get 0 is less than negative 1/2 times 0, which will just become 0, plus 4, or 0 is less than 4. Since that's a true statement, that means all of the points on the same side as 0, 0 will also be solutions to our inequality. So we'll shade the entire region of this graph below this dashed boundary line. You could also check this by choosing any point above this boundary line, say 0, 8, plug that into the inequality, and you would see that it doesn't make it true. That's not a solution to this given inequality statement. In example 10, we have a similar problem, but one of our changes is that now instead of a strict inequality, we have a greater than or equal to statement. Anytime we have that or equal to statement, we're going to use a solid line to graph that boundary line. We'll start off by identifying our y-intercept, which will be at 0, 3, and our slope, which will be 7 over 1. So to get to our next point, we'll go up 7 and over 1. And since we have that or equal to statement, we'll use a solid line to graph this boundary line. You could test this if we plugged in either of these 2 points. They would make that inequality true, so we use that solid line to indicate they are part of the solution set. Then we need to determine shading. 0, 0 isn't on our line, so we can use that as our test point, which would give us 0 is greater than or equal to 0 plus 3, or 0 is greater than or equal to 3, which is clearly false. That tells us that any other point on the same side of the line as 0, 0 would also not be a solution, and that every point on the other side of the line would be a solution. So we would shade this entire region above or to the left of the line, kind of depending on how you're looking at that line, but the entire side of the graph that does not include 0, 0. And you could test this. You could choose a point like -8, 0, plug it into that inequality statement, and see that it would make it true. Graphing problems like this in our homework system will be very similar to what we did with graphing equations, except now you'll have two tools to choose from. You'll need to determine whether you're using a straight line or a dashed line. In this case, we have a less than or equal to statement, so we want that solid line. We'll plot our first point at 0, -5, and then we'll move up 5 and over 8 to get to our second point. And then if you move your mouse or hover over with your finger, you'll start to see the shading changing. What we want to do is either click above or below, depending on what point, which set of points would make this true. Looking at this, if we plugged in 0, 0, we would get 0 is less than -5, which is false. So we would want to shade that area below and see that we get that question right.